started now. So Jim's out of town, so it's just me from FEDC here today, but we're really excited to have IGU Dan Britton from Fairbanks Natural Gas and David Prusak here today. Two people that are so common around this meeting. Don't need an introduction, or feel free to let us know what you want to share, but thanks for coming this morning.
Thank you. We appreciate the offer, and it's been a little while since I've been at this meeting, but I'm really happy to be here today because we have an amazing project going on here in Fairbanks, and one that we've been waiting for a long time that's finally here. As one of the ADA board members referenced it as the heart of the interior energy plan, and that's really what this is. A large storage project that underpins the rest of the expansion related to the interior energy project, and it's well on its way. So it's a great opportunity to share with you the work that we've been doing, and instead of talking about it, show you the work that's happening. And, you know, we've been talking about these things for many years, and so we couldn't be more excited to be working on this project and moving ahead with the interior energy plan. So what we got for you today is just kind of a little background, how we started out, and then really just picture heavy to kind of give you a look at what's been going on since we got approval for the contract from both the ADA board, approval for the funding to move forward with the construction from the ADA board in December 7th, I believe, and the IGU board on December 12th, and those dates might not be exact, but within kind of that range. So the ADA board approved the funding, the IGU board of directors concurred, and so that gave us authorization to move forward. So what the project is a large LNG storage tank. It's 5.25 million gallons of usable capacity. And when it's usable in a large LNG tank, you've got a certain amount of LNG in the bottom of your tank that is below the pump section. So you've got kind of a float in the bottom that stays there. And then you've also got some additional space capacity in the tank for vapor space. But this tank is 5.25 usable. Originally, when we began investigating this project, we were planning on a single containment tank design, which means you have your storage tank and then some sort of earthen dike or cement dike that performs your secondary containment. When we went out to update our RFP, we offered up the option for vendors to propose a full containment tank. Started to hear some discussion in the industry that full containment tanks, which historically have been as much as twice as expensive as a single containment, were starting to become much more competitive. I'm really pleased with the fact that the vendor or the contractor that we are working with put forward a competitive bid at or below the price of a single containment tank for a full containment design. So we are installing a full containment tank in this location, and operationally, the tank's a tank. You got LNG in it, pumps, but for your ability for future expansion at that site and for safety related to if there ever was a significant issue, the full containment does provide significant additional security, I would say, in that scenario. What it is the outer wall of the tank is designed to contain the liquid in a breach of the inner wall of the tank.
So how wide is that? How thick?
The outer wall.
How much space?
We'll go into some of the details, but there's 3 feet of space between the inner and outer wall that are filled with insulation. The scheduled completion for the project is the fall of 2019. Critical timing for us is that the storage tax credit that the legislature put in place for LNG storage facilities expires on January 1st, 2020. So we're moving as quickly as possible to make sure that we meet that deadline. And to the extent the legislature funds some of those credits, we will be in line and get the opportunity to recover them. As we work through the project pro formas and economics, we're not relying on that credit. in order to have a project that works financially, but it sure would be nice for the project. It's up to $15 million on our project. Our budget for this project is a total of about $48.6 million. 47 of it is what I'll call new money. There's about 1.6 million that Fairbanks Natural Gas, prior to Ada's ownership, expended evaluating and preparing the geotechnical and working on this project before when it was under private ownership, stopped because of the trends in the economy. So 47 is our current funding for the project. So we issued a competitive RFP in August, and our responses were due in October. It was for an EPC, engineering, procurement, and construction of the tank and the groundwork facilities that are taking place at the site. So all of the ground improvement and the tank itself. Balance of plant work, which is going to include pumps and vaporizers and trailer offload skids. We're going to do that through separate, smaller contracts. But the current large contract that's in place is responsible for the 100% of the tank construction, including the design and procurement. We completed negotiations through November and December. I signed the contract on December 22nd, and we began the work actually the following week. We started clearing the land on December 28th. So we've been, from the time we've received our funding, we've been going full tilt, as David would attest to. So who's our team? I'm the principal of the project, president and CEO of Pentex, which includes Fairbanks Natural Gas, Titan, and a couple of other smaller subsidiaries. David, who you're familiar with, has been working with IGU for quite some time as their project manager, is the project manager for this, for our project. CHI, who's a renowned, world-renowned engineering firm involved in LNG projects, is our owner's engineer. I would say that the individual that we have as our owner's engineer, he must be, if not the most experienced related to construction and operations of and maintenance of LNG tanks. He's got to be right there with maybe a couple of people. So it's great to have him on our team. Design Alaska here is going to do the balance of plant engineering for us, and they're actively working on our designs for those facilities right now. We've got Alaska Test Labs, which is doing all of our QA services, and our quality assurance on top of all the work, the QC and QA that our contractor is doing. This project has an immense amount of quality assurance and quality control work that goes on. The inner tank, which we'll talk about, it actually gets 100% X-ray on all of its welds. And so, you know, there's a lot of quality assurance. The whole time we were doing the groundwork, we had the geotechnical engineer on site to make sure that everything was being done exactly to the specifications that have been developed. So.
Where's the Alaska Test Labs located?
So they were formerly, I think they used to be Alaska Test Labs, then they were a part of Dow, and now they just, so when we first had them starting to do work, it was with Dow, and then now it's back to Alaska Test Labs. Primarily they have a test lab here, but they're in Anchorage as well. We have a significant amount of work on the outer tank that's taking place in Anchorage, at Anchorage Sand and Gravel. So we'll kind of show you that in a few minutes. Although the contractor is out of Quincy, Massachusetts, there's not that many that have experience in building cryogenic LNG tanks. So we limited our RFP to those that had direct experience with building those tanks. Include companies like CB&I, Matrix, Preload Cryogenics, those types of. What we're really pleased with is the amount of work being done by local and Alaska contractors. In fact, almost all of the work to date has been Alaska contractors completing the work. Great Northwest did all of the site work, all of the excavation. They'll continue to do the site work that is necessary. American Tank and Vessel, that's a company that's out of Houston. They're doing the inner tank, the specialty 9% nickel. Again, that's part of the specialty work. But Anchorage Sand and Gravel, they're doing the outer precast panels. And so that's a significant portion of the work that's being completed. So they're going to precast the outer tank panels and bring them to Fairbanks.
So it's concrete.
The outer tank is concrete.
Will they erect those as well, Dan?
No, the tank builder will erect those.
Oh, I see.
Yeah. And that'll be preload. That'll erect those with the Alaska Crane Company. They're still finalizing who, based on what size cranes available, and you know, crane mob and demob to the extent you can coordinate with some other projects that might be happening. So they're still in the works of finalizing who their crane contractor is going to be. And there'll be probably one or two. There's going to be at least they're looking at whether they can do the roof pick with one crane yet or not, and get that crane big enough for that. So that we should know pretty soon what their approach is going to be.
Okay.
Golder and Associates, which is again Alaska engineering firm, has done all the geotechnical design, Arctic foundations, all the thermosiphons and installation. Rady Concrete, a Fairbanks contractor, is doing the flat work. That's the tank concrete foundation. You know, we've had Diamond Fence, and then we'll have Fulford's doing all the on-site power. Precision and or Alaska Crane. MAPA Testing is our testing lab that's been doing all of our QC work, and Alaska X-Ray or others will be doing all the X-rays of the welds. So this shot, which is also shown on the board over there, gives you just this is an overview of what the site looks like. You don't need to pay attention to the small dots and lettering. Those are some of the geotechnical locations and things that are just depicting some of the work that was done. You can see on the top of the north there, the large circles, that's the tank. The stuff down to the right is our existing facility that's remaining in operation. And as you move south from the tank, you can see a rectangle there and a couple different pits. That's the balance of plant work that's going on with this tank. So in addition to the tank, we are installing enough vaporization and pumping and heating capacity for the growth of the interior energy project, for us to expand into 5 to 8 BCF of total capacity in the system. So, for example, in the tank, we have 3 pump columns. Each pump column is rated for 100% capacity of the system in the future. So we have redundancy in our pumps and our pump columns. We'll have it installed 3 pumps, so significant redundancy. The vaporizers, we're installing them as 3 50% units for now, and then we'll add additional in the future, and the same in our boiler capacity. Down in this area here, we will be reworking this and installing new offload facilities that will have the capability of taking LNG straight out of the trailer into our vaporizers in the event somehow we weren't able to get LNG out of the tank, and we had some reason where we had the temporary inability to get LNG from the tank. We could take LNG straight from the trailers into the vaporizers into our system. This gives you just a kind of overall look of what the tank's going to look like. Dave, maybe you can point out a couple of the. So we've got the inner tank. Can you point out the inner tank wall? So the inner tank, that's 9% nickel steel. That's containing the LNG at minus 250 to minus 260 degrees Fahrenheit. We've got the annular space of the tank. That's the 3 feet. That annular space is going to be filled with perlite. And I don't know if we got any gardeners here, but if you know your garden soil, you've got perlite in your garden soil, and so it's a lot of perlite. So it's going to be shipped up here and then popped, is what they call it, basically heated to where it expands. And when it expands, that creates all that airspace and becomes a good insulator. So 3 feet of perlite, and then a 10-inch precast outer concrete wall.
What kind of R value does that have, you know?
We don't look at it in R value. I don't know what the R value would be. We look at it in boil-off rate per day, per hour, and our specification. So when you're designing an LNG tank, it depends what you're designing it for. When companies use them for peak shavers, which is in the rest of the U.S. mostly what the large LNG tanks are for, they'll have the LNG sit there for quite a long time, waiting for a peak winter cold day, and then at that point they take a lot of the LNG out of their tank and vaporize it into the system to bring the flows up to meet the peak. Our tank, we've got a constant flow out of the tank, so we're not really trying to hold the LNG in there for any particular reason. So as long as our boil-off rate is below our minimum system use, that's kind of our baseline. You know, we don't want to use too much boil-off compression, but as long as we're like well below what the minimum system usage, that makes sure we don't have any loss of product. So any of the boil-off, the gas is compressed and it goes into our distribution system.
So there's no vapor going to the atmosphere?
There's no vapor going to the atmosphere, no. Under the tank, you can see we've got, it's a 5-foot thick outer ring wall, and then a 3-foot thick mat under the inner part of the tank.
Soil preparation under that, pre-preparation.
The pre-preparation of the soil is we removed all the organics and silts down to frozen gravels.
See that in the next slide.
Yeah, we did a significant amount of geotechnical work on this property before we began, including driving piles, monitoring ground temperature, doing load tests on piles. We actually had the university involved. They were quite interested in the work we were doing as far as doing the ground monitoring stuff. As foundation design advances in Alaska, and you have to take into consideration degradation of permafrost and things like that, it's important to understand what's going on in the ground and the temperature.
So this ground is frozen, and with thermosiphons, you're going to keep it frozen?
Yes. So this ground below the silt and frost, so we have about 12 feet to 18 feet of silt-laden materials. Below that is frozen gravels for about 100 feet. Mm-hmm. And so, like the Great Northwest Pit that's just to the north of us, they've been pulling gravels out of that pit for years and years. I don't know how deep it is now, but it's deep, and they're still pulling gravel out. So below that 10 feet of silt, we've got great ground, but we need to keep it frozen. We want to keep it frozen, so we are. And I'll talk to you about a few things we're doing to ensure that.
Did you install some thermistor strings and stuff so you can monitor, what's happening?
Yes, we did.
Did you excavate the organics?
Yeah. So what we've done is, and we'll maybe. So here's a shot of the foundation essentially. At the bottom of we've got a thermosiphon, flat loop thermosiphon system. Above that, we've got a layer of gravel, and then 4 inches of insulation, and then backfill beyond that. In a couple of locations, we do have the thermosiphon.
The thermoprobes here, and then we also have thermoprobes right at the level of the refrigeration tubing, where the Arctic Foundation.
Thermistors, sorry. Yeah. So monitoring the ground temperature. So we'll have a complete picture of the ground temperature below this tank for.
Then pretty soon you can model it.
Yeah. So for now, it's the geotechnical engineer is monitoring it through a data logger. Once we're in service, we'll continue to monitor it in our SCADA system and be able to adjust any of the cooling needs we have. You can see on the outside, around the perimeter of the tank, we will have passive thermosiphons installed, and those will be the primary cooling aids for the ground. The system, the flat loop system that we've put in place now, is designed to keep the ground frozen during construction activities. We can't have those thermosiphons in the way for when they're building the tank. in addition, we don't think we'll ever need it again, but if we did, we have a means to mechanically add refrigeration to the ground if we don't get enough ambient cold to keep the ground cold enough with the passive thermosiphons. So we have backup to the.
Yeah, during the course of construction, these will actually be active, and we'll have a compressor on those flat loops, and they'll be operating to freeze the ground.
It seemed like 260 degrees below zero would keep that ground a little bit.
That's the idea.
So first, when we're getting in final design, we're having a number of our conversations that we have, and I start hearing that we're going to be putting a heating system in the bottom of our tank. And then, so obviously that's counterintuitive to what's going on here. Okay, I'm spending money on cooling, and then you're going to put in a heating system at the bottom of the tank. What's going on here?
It's not even the Army.
Yeah. So we get in the conversation with the geotechnical engineer. The problem is we want the ground cold, but we don't want the ground too cold to the point where it begins to wick water from outside of our area, which could create an ice lens. So if we don't create that thermal break between the bottom of the LNG tank, first of all, it's created with 3 feet thick foam glass insulation, and we have heating conduits that you'll see in pictures that have been installed that we're going to run glycol loops through that we can run if we need it. We might not need them, but we have to create just a thermal break between the LNG and the ground, so we don't somehow get the ground temperature to -20 instead of 30 degrees and start creating the wicking of the water. So this is the start of the project. We're starting the excavation. You can see they're digging. They dug in January. They did the clearing in January and began bringing our gravel pad around the site up in January. They're at this location. This is the tank area, and digging through the frozen silt-laden grounds. This is a little further along in the excavation process. You can see to the north at this point, the tank excavation is primarily completed. Where he's working right now is in that balance of plant area I showed you, and down where our multi-use building, which we're calling it, will have our control room and our boilers for our heat source for the vaporizers.
What's that mountain in the background there?
That's the gravel that we're using to fill this hole as we dig it. So
Temporary mountain.
Yeah, that's Great Northwest stockpile. So it was ideal for this project. They built a nice road from Great Northwest facilities across the flood channel to the north and a rail spur. And we had direct access from Great Northwest pit into this property. Because they have such a substantial stockpile of gravel, it really made doing this earthwork in the winter much more achievable. In order to we had to get 95% compaction on all of our backfill. And so what they're able to do is break into their pile, the crust on the outside that's frozen, gravels, set that aside, and the inner part of their pile was still in the 30 to 32 degree temperature range and didn't have ice chunks or anything in it. So that's the material they could use for backfilling. And then we added warm water, 70 degree water for the compaction, and we were obtaining 95 to 98% compaction on all the backfill of the gravel.
Beautiful frost-free material. Its maximum density was 5 pounds less than concrete. It was 144 pounds a cubic foot.
Is it just straight pit run, or has it been?
Yeah, well, it's done, they pull it up below the water, so I think a lot of fines wash out of it. So, I mean, it's less than 1% passing at 200 sieves, so just beautiful stuff.
So these pipes you see here, that's the flat loop thermal siphon system. And so all of those pipes run from the balance of plant area, all under the complete perimeter of the tank bottom, and designed such that if we were to lose a number of those individual loops, we would still have the cooling they're charged now. They're providing some level of cooling, but the compressor, the refrigeration compressor, won't be hooked up until the end of this week. Every step of the way, we had to deal with the snow, and they had to hand remove, especially once we started putting these the thermosiphons in the ground loop. They had to do all this by hand, and leaf blowers, and so you know, with each lift, it had to be snow-free, and so it was a lot of work for the crew on hand. Great Northwest and their crew did an amazing job on the work on the excavation and backfill and the preparation for the site.
Can we get them to come out and clear the snow for our garden?
So this is a good shot that shows the thermosiphon, the ground loops coming back to the risers for the thermosiphons. Beyond this point, they actually were extended after part of the backfill was done. You can see the difference between the ground prep, we've got compacted backfill underneath the piping network there. You can see the transition down to where the excavation is still continuing. The materials you see closest to us, that's the silt-laden materials that's being removed. Most of the material was removed and then placed on adjacent to our pad on our properties. Some of it was removed into Great Northwest that we'll reuse for probably topsoil. So, yeah. Yeah. Here's the installation of the foam. So the ground loop is complete. 4 inches of 100 psi foam. It was installed in a grid pattern. Then after that, they began backfilling in lifts of 8 to 12 inches, and at each lift getting their 95% plus compaction. So you can see the transition. They've just started to backfill the pad after the foam placement. This is one of the Design Alaska engineers is a pilot too. So he was out flying one day, so he got us an aerial that gives you a good overview of what the site's looking like. You can see our existing facility in operation within the fenced area, the tank area, excavation complete at that point, and they were moving to the south for the balance plant excavation work and where the piping for the flat loop system went. Right down here at the bottom of the picture, that's the over excavate materials that are being placed and graded on the site. The site is wetlands, so we have a wetlands permit and had to purchase 11 mitigation credits. And so those mitigation credits actually come from the Chena Pump area. So the green belt area and the Chena Pump that they've been developing off the Chena Pump. Here we have completed the backfill now. As part of the tank foundation, we placed a perimeter around the tank in the 5-foot thick area, a lean concrete mix, in order to have a work surface that they could work from for the
Sense of where that would be. It's back underneath that ring wall there, and that's what you see here.
yeah.
Like a rat slab?
Yeah.
Yeah, and then you can see the flanges that are all the way around. Those are bolt supports for the, there's 108. So those right there, those are, you'll see in another picture, are supporting the bolts that will be holding down the tank. In addition to the foundation's just, it's pretty cool.
Where'd you get your concrete?
This pour came from University, I think. The remaining is going to be all 3. So the pour that's going to take place on Thursday, it's 1,800 yards, and we're doing it in a day. It'll be 3 pumper trucks and operating at the same time, we'll have a fourth on site as a backup. We actually have our pre-pour meeting with everybody tomorrow morning.
Has that ever happened before?
That big of a pour? Yeah, well, we thought we were the big dogs, but the university pour was for the, yeah,
For the
so,
power plant? Okay.
yeah, but we'll find something to make us.
It's still on here.
It is, it's still a huge pour. Yeah.
Is a tank like this, is there a, particular or seismic design consideration?
Yeah, substantial seismic design considerations, and that's really.
You were planning that question for
Yeah. So what you can see here is really what the results of those seismic considerations are. First of all, the tank foundation has approximately in excess of 90,000 tons of steel, rebar, and then what you see up at the top, those crisscrosses, those are seismic cables. Those seismic cables go around the entire perimeter of the tank, which hold the tank seismically to the foundation. And then they have within them flexibility and some design so the cables can move somewhat, the tank can shift. And we'll be monitoring the inner tank where the inner tank is in the event of a seismic event in relation to the outer tank. So we'll be able to see if there's any movement that goes on.
So John, if you look over here, these cables, and they'll be in three different directions, they'll attach to the outside of that wall. These are Nelson studs that come out that will actually attach them to that, and they will be tightened up along that edge here before this outer edge is shotcreted in. But that is how it'll connect to that tank all the way around.
Can you point out the bolts for the inner tank?
And then and so then the anchor bolts that you saw coming up, that 108 that Dan was talking about, are here for the inner tank. This will be the inner tank inside wall will be just inside of those anchor bolts.
And then the outer tank anchor bolt has a box design that allows for some movement between the inner tank and the anchor bolt. So in a seismic event, they can move somewhat.
Dan, is there a special concrete mix? You've got three companies supplying concrete. Is that kind of a standard mix, or is there a special mix so that you have consistency between the three that are producing it?
It's a fairly standard mix, but it's a design mix. It's not something they have never mixed before for another project. It's 6,000 PSI, I think, is the 7,000 is the tank foundation PSI. The outer walls are 7. The tank floor is 6. So it's fairly standard.
So it's pretty standardized throughout your producers.
Yeah, they have to meet the requirements for foundation for multiple projects. So most of the batch plants have the capability to meet differing needs. We will be doing a significant amount of testing of the concrete first load. In our contract, the contractor is required to test every 150 yards, and then we will do our QA every 450 yards, and it'll be on each plant. And then I don't know how, there's going to be between the two of us probably 45 or more cylinders that are poured, and brake tests will be completed on all the cylinders before we move beyond after the foundation curing. You'll see also, do we have a picture that shows the cooling loops? We'll see.
The heating loops, we've got the heating loops.
How about not the cooling loops for the curing of the concrete?
Yeah, they'll be in the picture. Yep.
So here's the start of the mat of the concrete foundation. This is the base mat. You can see the bolts that they're placing. They've got some of them done around the perimeter. Those are the bolts. Those are the supports for our inner tank bolts. all of this work is being surveyed as they go.
Brady putting all that rod in?
Ironworks Inc. is doing all the, and JB Weld out of Wasilla did all of the rebar, preparation. JD Steel.
Yeah.
Oh,
JD Steel did all the rebar preparation. So here you're starting to see those seismic cables that we talked about. They're starting to be placed, continuing with the rest of the rebar work. You can see they've got the risers, those pyramid-looking shapes in the middle that are supports from the bottom mat up to the top mat.
There's those cooling loops in the white.
Yeah. So what we also have is,
How are the bottoms of those seismic cables anchored?
They're within a rebar mat itself, but then, they're just U-clamps that actually pull the cables together, to cinch them down. I think I've got a close-up of that.
so if you can see the white PEX tubing pipe that's going around the perimeter of the 5 feet section of the foundation, that's cooling line for curing. So when we're monitoring the concrete temperature during the curing period, they can run cooling water in order to ensure that the concrete's not curing too quickly or getting too hot. So we'll be able to make sure that we get the ideal curing temperatures while it's going under after the pour.
You're making me think part of that is weather. You're on track, you're on schedule too, right? So that you're in the weather you were hoping when you.
We're on schedule.
Yeah.
So everything's on schedule right now. So that we wanted to get this pour done before weight restrictions. We've got it. We're going to be done by Thursday on the pour, and then you'll see we've already started pouring we've completed the first outer wall panel in Anchorage, and the outer wall panels are scheduled to begin arriving in the first week of June. And with getting through the winter, getting all this excavation work done, dealing with some couple weather delays, and the amount of snow that we had to deal with this year, the crews have done an amazing job of staying on schedule, on task. Here's a little closer look at how the seismic cables get finalized in place. They built a support system that goes around the perimeter of the foundation wall,
here.
and then they get fastened because they want those to be in exactly the right position after the pour. The anchor bolts you can see that are going around the perimeter, the steel that you see there, that's when the pour is complete, that comes out and goes away. There's a nut underneath that, and then a nut on top, and what that does is they set the elevation of the anchor bolt, and they can survey the elevation of the anchor bolt, and each bolt remains perfectly in the location it requires. The specs plus or minus 1/4 inch on anchor bolt location, so these won't have any play in them. They're locked in place. You can see the seismic cables have a 2.5 inches of foam around the cables where they'll be in contact with the concrete. That's so that the cables don't get into shear in a seismic event. They need to have some movement, but the bolts will be rigid. Some continuation of the mat and the placement of the supports for the seismic cables.
Note here is that, the steel that you see here, they call it cryo bar or cryo steel. It's a specially manufactured, rebar meant for, cold applications that performs very well in that minus 260 degree, temperatures that it'll see. The other thing, the appreciation is that you can just see how much steel is in that thing.
what's the diameter?
The outside diameter is 120.
No, I'm thinking of the steel.
Oh, there's a variety of different sizes. I mean, there's everything from 4s to 7s throughout the whole thing. These are 7 bar underneath here. The majority of this is 6s and in sixes and fives.
Yeah, the cryo bar that, David was talking about, that, so the foundation, in the event there was a spill from the inner tank to the outer tank, the foundation's designed not to fail, so the cryo bar will withstand the cryogenic temperatures, so the top mat of this is the cryo bar.
Here's those heating, pipes that that Dan had talked about there, that we have to add heat afterward, as we monitor the temperatures down below. If we have to add heat, that's how, and where they're at, that's stainless steel.
You can see the ends of them poking out the foundation wall,
Yeah.
just right there. Where's the video? Is it coming? Did I?
Back up on, this one. In fact, I think hover down near the bottom here, and it should be able to get to,
There we go.
Oh, boy.
Rady flew a drone. They do one at the end of each day or so, and they centered it on the middle, and the thing flies a perfect circle around the whole darn tank. It just really burst.
And we are doing as well, we're videoing the complete construction activities. So at various periods of time, we'll have a time lapse. I didn't have one scheduled for this presentation, I apologize, but in the future updates, we'll have a time lapse to kind of show you the work as it's taken place. So where we're at, the excavation's complete. After the foundation is poured, we'll have additional backfilling. The 9% nickel steel is ordered, and as with any project, things that you never thought you'd have to deal with, you have to deal with. So when Mr. Trump imposed tariffs on steel tariffs on steel, or the call from the 9% nickel provider to our contractor was, we are not paying these tariffs, even though your contract requires the materials delivered. Tariffs paid, FOB the U.S. If you want this steel, you will agree to pay the tariffs. Our contractor legal says, no, you got to pay the tariffs. They said, well, we're not building your steel, sue us. And so obviously that's not a good thing for our project. Ultimately, we agreed to take the risk on the steel tariffs, which is about 25% and about $500,000 for this project. Because of the moratorium, I guess you could call it, or that until May, we'll get a bunch of the steel done before then, and we're hoping at least, this material comes from Belgium. We're hoping we'll still see a exemption from the European area, and we'll ultimately be exempt from the material. In addition, there is a blanket exemption in the language that if the materials aren't made in the U.S. in similar quantities and quality, then you can receive an exemption, and there's nobody producing 9% nickel in any significant quantities in the U.S. any longer. So we feel confident we'll be able to get through the issue, but it's enough to cause you to get gray hair for a couple of days.
So say again, your sourcing of some of it's Belgian, and where's the other source for the steel?
All the 9% nickel steel is from Belgium.
All of the 9%?
Yeah. The carbon steel has been ordered from some U.S. Steel companies, but it's the 9% specialty nickel steel that's all from Belgium. That's our only.
Cryo steel came out of Arizona, and then the carbon steel was, throughout the.
Yeah, that's our only risk area, is the last order of the 9% nickel steel that won't be here before May for the inner tank. So the rebar, as you've seen, is placed. The foundation pour is scheduled to be completed Thursday. We're doing our pre-pour meeting tomorrow morning. the flat loop evaporators, the thermal siphons are in place. The compressor was being installed or arriving yesterday afternoon when I was out at the site, and the temporary power is almost complete. The outer wall design is pretty much finalized. The fabrication of the first panel is complete. You saw the temporary fencing, and we're about to place our first long lead balance of plant item this week, which is, so we're, as the owner, we're ordering directly our long lead balance of plant pieces. So the LNG pumps, the vaporizers, the boil off gas compressors, our bigger boilers, we're going to control those specifications very closely in the timing in which they arrive for the site. So the pumps, part of the pump has to be installed when the inner tank is being completed. The pump manufacturer provides the suction housing essentially that gets welded to the pump column. So we provide that piece that the tank builder installs.
Who are your pump suppliers?
So the pump supplier, we went out to bid from multiple suppliers. The one that we're looking like the order is going to be is called ACD, and they're out of California. So they're an American pump builder. We had quotes from Cryoquip, Vibara, ACD, and Nikiso, a number of different. There's probably 4 or 5 now that are LNG and tank pump builders you can get. So ACD was the lowest price for us, and actually they also had the smallest required pump column size, which is important because it saves us ton of money. The pump columns are hung from the roof of the tank. It's the best way to deal with the seismic activity related to the pump columns. This is in Anchorage. This is the preparation of the first panel. As you can see that in the bottom, so the panel have the steel, the form, that stays part of the panel. So when the panel arrives, it has the steel is part of it. Once those panels are erected, there's cables wound around the entire tank and then shotcreted on the outside of that. So, David, you have the number off the top of your head. You like
3,120 studs are put into each one of these 43 panels that are being precast down in Anchorage, and so this gives you a sense of what the level of effort is. And as we talked about, Anchorage Sand and Gravel is the ones that are actually doing the precasting facility just adjacent to the yard on the other side of Minnesota Avenue is a metal fabricator called Weona, and they're actually the ones that are responsible in the fabrication of not only getting the studs in, but there's also, you may see that rounded, that they roll that steel, or they're welding those pieces together, and then placing the studs. And then at a variety of locations, you'll see rebar like this, cages that'll be set throughout the panels so that it has the strength to be able to be picked, to be pivoted, and still maintain its strength. And these are 88 feet long that are getting poured, and you'll see what it looks like.
What's the width?
That's about 8 feet, approximately.
Can you point out the tensioning cables there?
Yeah. So then the cables will be here, and we'll see it actually in the next picture. The next picture coming up.
So those tilt up and they're kind of like a barrel stave?
Yeah.
Yeah. Yep. And then it's pre-tension cables that run through here that they'll tension before they cast.
Yeah, they're tilted up, like you said, and then they're connected with a weld. Yeah. And then the shotcrete.
Yeah, and then wire long, like a silo, like a grain silo would be. There you can see the cables now that are ready. They're getting ready to tension those. And here's the first one of the panel.
Those cables are tensioned to in excess of 40,000 pounds. before the pour.
And then as the concrete cures, they're actually steam curing this so that it hits it within 24 hours. It typically is hitting 4,500 PSI of strength, and then they'll detension. But then ultimately, the concrete for this is 7,000 PSI concrete.
Yeah, before they move them, they need to reach 5,000 PSI, so that will break cylinders before they are moved. The goal is for them to be pouring 1 a day.
They'll be shipped up here end of May, 4th of June is when
So by
it's gonna start coming.
from the time they start arriving, we'll have panels arriving in time so they can just erect them as they arrive.
Right now, they haven't determined that yet, whether it's rail or truck, 'cause, and it's, you know, all the pick points and how they can balance it, you know, whether there's gonna be 8 or 6, points of which they can be having that movement. Yeah, exactly.
Yeah, they're finalizing some of the calculations on the stresses imposed based on some of the proposals from the trucking companies on the style of trailer they would use to handle these things, so.
But likely truck. not rail.
Likely truck, yeah. There you can see that the pour is, they're completing the finish. This is a completed panel that is now staged and ready for shipment to the job site.
How long is that,
88.
88?
You can see the cables sticking out of the bottom there. There's also lifting loops that are cast in there that they're able to pick and grab the panels as well.
So you're on duals then when you haul that?
On duals, what do you mean?
Well, what kind of I guess I'm interested in when you load it on a trailer, what it looks like.
That's the question, was the type of trailer right now, whether it's they have stretch
Dan, what
decks.
can you tell us?
Are you going down the road?
Yeah,
You guys are hauling it?
Well, I don't know yet.
I think they're still working out who their transportation contractor is gonna be, but they're,
Glasgow West would be looking at it.
generally probably some stretch decks, or they'll have some of it might be able to span between dollies or between the drop deck and another deck. So our next steps, we're gonna, as we talked about, turn on the flap loop evaporators here, probably any day. We'll backfill the remainder of the pad once the pour is complete. We'll continue to fabricate the outer panels. The inner wall fabrication, so the inner walls will get rolled and prepped, the steel prior to being shipped. So when it arrives on site, it's prepped to begin installation. And they also fabricate all of their components related to the foundation, attachments, and everything in their shop before they are sent out. The long lead time items for the balance plant, we're out for quote right now on the vaporizers and the compressors. We're getting ready to issue our pump order. We haven't sent out the quote for valves yet, but we will soon. Our second submittal to the fire marshal will be submitted any day, and that's for the tank itself. We have our first submission was the foundation. We'll have 4 total submissions to the fire marshal: the foundation, the tank, the balance plant, and then the overall site security area. And the dome roof design is under its final details. Final design engineering. The dome roof, the plan right now is for the roof to be built just to the west of where the tank is and be picked in one pick. So, but that requires a big crane.
Yeah.
Where they're in the intertank builders that are going to pick the roof were in town last week and trying to finalize what cranes they have available and what they can rely on. So we'll know here shortly whether it's gonna be a single pick or they'll have to do it in multiple picks. That's it.
Any
5
questions?
minutes to spare.
Holy cow.
Quite a project.
Yeah, it's fantastic. It's like I said, a long time coming for the community, but really it's an awesome project to be a part of.
Yeah.
Who did most of the cryogenic engineering on this thing? You mentioned somebody from California. I know that.
So CHI Engineering, who's our owner's engineer, they're out of Boston area.
Moved to Massachusetts.
Yeah. And so they're our owner's engineer, and they're working with Design Alaska on all the balance of plant work, bringing the cryogenics expertise. Design Alaska is using the, familiar with buildings in Fairbanks, and
It seems like it's really an immense undertaking.
yeah, and then
You don't realize what goes into a cryogenic
no, and then the
problem like this.
yeah. So our owner, so our owner's engineer, who has probably, like I said, the most experience in tanks and their construction and operations is anyone. And then Preload Cryogenics has an impressive team of engineers on their team that are doing their design work, and we're double checking all of their design work.
Yeah, it's impressive.
So Dan, long time coming for this community, the storage capacity, of course. Can you, and when this was originally envisioned, I guess I'm trying to understand scope change, which translates, of course, into a more expensive ultimate project than it had originally been discussed. Can you give a layperson highlight of that? Just because you've been on the ground working, essentially wanting to do this for some time. So now that it's costing us a lot more than when we wanted to start or when you wanted to start.
Well, I don't agree with that statement first.
You don't?
No.
Oh, okay.
A lot more. So when we started the project in 2013, 14, began the work, geotechnical, everything else, our budget was $42 million.
And that was all in.
That was all in. And so 4 years later, our final budget, including the expenses that were completed, is a total of $48 million. We also now are under public ownership, so we had to move to Alaska Wage and Hour Act laws, require Davis-Bacon wage pays. When you look at a project 4 years after its initial thought, initial development to a final investment decision with a difference in budget of about 10%, when you say a lot more, I don't agree with that being a fair
I thought it was
characterization.
I thought the original was 30, and so that's the number in my head. And
no, we've had $42 million in our performance as this project is moving forward for a long time.
Okay.
Yeah.
That's helpful.
Yeah.
Thank you for that context.
Yeah. So
The other context is the fund source grant versus the credit.
So this project, we have $1.5 million of the engineering work was through the grant because that was allocated as part of the additional feed work before we got final investment decision. The remainder is through the sets funding the loan funds for this component.
Well, we're relying on credit, the tax credit to still be available for us through, January 1st of 2020.
Yeah.
To be able to help support that.
So not relying on it, we're hoping.
Well, we're hoping for it. Yeah,
And I
that's
guess
thank
there's
you.
some nuanced on that, and I haven't heard lately about the morphing of the most recent plan. As far as you understand, are you still able to access and utilize the credit under what's been discussed with this bond-funded approach?
Yeah, as far as we're aware, and Gene Terrio is the IEP team lead for ADA. He's been doing a great job in Juneau for us as a community and staying on top of all of this and making sure that any of these changes don't impact our applicability or our availability for us. So our big concern is where we sit in the queue when we get the project completed and our fund request in, and whether where they are at with the credits that are outstanding. So to the extent credits get paid, we feel like this project qualifies.
Are there any questions on the phone? Thank you, Dan. Appreciate your time.
Yeah, thanks.
And next week we'll have some GBA vice presidents here presenting. I don't have their names with me right now, but they'll be in the email I send out today. Corey wasn't able to come and present on the impacts of the MLMP sale and changes, and kind of an overall the changes that will have on our energy and our electricity up here, but also just a general update on GBA. So
I'd like to make a couple quick announcements. Just to remind people that Chris Rose from Renewable Energy Alaska Project is presenting tonight at Cold Climate, 7 to 9, and the topic is clean energy, renewable energy. And he's also looking very, I'd say intently at the consolidation of the 6 railbelt utilities, so that there would be better management of renewables instead of one small company like or co-op like Golden Valley trying to manage wind and solar and whatever all through the railbelt. Apparently that's what he's been working on in Juneau. We'll hear that tonight too. Also, I'd like to bring attention to this book, and it's called Drawdown: The Most Comprehensive Plan Ever Proposed to Reverse Global Warming. It's edited by Paul Hawken. You might know him from Natural Capital or from the Hawken tool catalog, Smith & Hawken, I think it was. It came out about 20 years ago. Anyway, he's quite a noted writer, thinker, and in this, the makeup of this group of scientists, engineers, technicians, artists, poets perhaps, I don't know, but about 200 people worked on this, and they came up with the top 100 measures to reverse global warming. And number one, surprisingly, is air conditioning. It's because of the gases used, and we're talking about planetary, we're not talking about Fairbanks, Alaska, because we don't do that. But number two is onshore wind, in terms of efficacy of reducing carbon in the atmosphere. And number 6 and 7, 6 was educating women. Number 7 is birth control, if you think planetary or globally. And unfortunately, net zero homes, which is my interest, is number 79. But, and it's all 79th in this ranking for reducing carbon. Okay. You might make more money not burning energy, but what we're talking about is reducing, or he's talking about is reducing the carbon in the atmosphere. It's a good book. I've sold about 20 of these. What I do is, when I can get 10 people that are interested, I'll go order 10 and I get a discount. So instead of $22, I can sell it for 20. Get 10%. So if anybody's interested, let me know.
I got mine on my coffee table.
Okay. I think it's a very important book. And if you're thinking in terms of clean energy, which it seems everyone wants to know more about, tonight at Cold Climate.
awesome.
He's also presenting at the Rural Energy Conference. That's why we were able to get him. He's here.
See you all hopefully next week.
Good to see you, John. Good work again. Thank you. We have a project.
I wonder if they're able to do any
That'd be great.
changing of subterranean volcanoes and seas,
Good job, Jeff.
straightening up the axis,
That's one hell of a
polar
project.
axis of
Yeah,
the
we're-
Earth.
Great.
The wobbling of the Earth around its itinerary, which all